Okay, welcome to section 2.1, Relations and Functions. Okay, this is going to be the first video of a set of videos for chapter 2. And today we're talking about functions and relationships. So if I talk about a function, right, I'm talking about something that's functional or that works. So when I talk about a function, I want to think about a vending machine. So when you go to a vending machine, you want to go and you want to, like, let's say you want a drink, right? So you want soda. How do you get that soda out of the machine? Well, obviously, first you need to put in the money. Then you're going to hit, let's say, A4. If I hit A4, what is that output? That's going to output, let's say, a Pepsi. That's what I want. I want a Pepsi. So that's something that is functional. Okay? But what wouldn't make sense is I went and wanted a Pepsi and I hit A4, output a Pepsi, but my buddy behind me also wants a Pepsi. So he's like, okay, I'm going to hit A4. But when he hits A4, a Coke pops out. Okay? So does that make sense if I hit the same button he did and both of us outputted two different objects? No, that wouldn't make sense. So in that case, if my second, if the second time I outputted another item, it would not be functional. But it would be functional if every time I inputted or pressed A4, it would output a Pepsi. Okay, so when I talk about functions, I need to understand some vocabulary words. Some of this information you might already know. But relationships that can be represented by a set of ordered pairs is called co coordinate. Okay, now a coordinate could be represented by, in my case, if I'm talking about A4, right? I'm talking about A4, and it outputs a Pepsi. I'm just going to write P for Pepsi. So my order pair is A4 comma P. Right? Now, what if I want to talk about like numbers? Okay, if I want to talk about numbers, I want to say, okay, well, let's say 1 comma 4, right? That's an ordered pair. We understand that that first value is always going to be my x value. My second value right there is going to be my y value. We understand an ordered pair like that. Okay, cool. Now let's talk about some vocabulary terms. Okay, the domain of a relation is a set of first coordinate or x values of the ordered pair. So in that case, if I'm talking about x comma y, my x value is always going to be part of my domain. Okay, and my y value is another type of value that we'll talk about in a moment. In my example of A4 comma P for A4 and Pepsi, my A4 is going to be my domain or my input, and my P is going to be something slightly different. I'll talk about that in a moment. And in my example of 1 comma 4, the 1 is part of the domain because it's the first set of values like that. Okay, cool. Next, okay, the range of a relation is the set of second coordinate, the y value. Okay, so it's the opposite of the domain basically. So I'm not talking about my x, but I'm talking about my y's. Okay, so now my y is part of my range. So in the case of A4 comma P or Pepsi, my A4 isn't part of my range, but the P for Pepsi is. So that's part of my range. And lastly, I have 1 comma 4, and 1 is not part of my range, but 4 is part of my range. Okay, cool. Lastly, a function is a special type of relation that pairs each domain value with exactly one range value. I'll get into that in a few moments, but understanding that uh, every time I plug in A4, okay, it's only going to output a Pepsi. Only going to output a Pepsi. It cannot output a Coke because then it would not be a function. Okay, so let's get into some mathematical data that we were going to kind of distinguish whether something is represents a function or not. Okay, so we're going to do it 3 different ways. I think the easiest way to understand is looking at a graph. Okay, but there's a couple different types of ways that we could determine whether it's a function or not. Okay, so if I want to look at a graph, obviously all I'm going to do is plot those points. So if I'm going to plot 2 comma 3, 4 comma 7, 6 comma 1, so I'm going to do that. Remember, I'm always going to start at 0. My first ordered pair, for the first coordinate of my ordered pair is going to be 2, so I'm going to go right 2, up 3. So that's 2 comma 3. Okay, then I'm going to go 4, 7. Slightly off the grid here, 4 comma 7. And then I'm going to go 6, 1, which is right there, 6 comma 1. Okay, good. Now I'm going to represent that information looking at the diagram, okay, a mapping diagram. So you might not have heard of a mapping diagram before, or you might have seen it before. Okay, a mapping diagram, simply all I'm going to do is I am going to list my input values. Now when I talk about my input values, another name for those would be my domain. Okay, so when I talk about my domain, I'm talking about my first set. So in that case, I'm talking about the 2, 4, and 6. Right? So I'm going to list those downward in my input column from least to greatest, least to greatest without repeating. Again, least to greatest without repeating. So in that case, 2, 4, 6 is in that order. So I'm going to go 2, 4, and 6. Awesome. Next, I am going to write down my output. When I talk about my output, I'm talking about my range value. Okay, my range value. Awesome. So now I'm going to write down from least to greatest without repeating. So let's look at those items. I'm talking about a 3. I'm talking about a 7. I'm talking about a 1. So 3, 7, 1 would actually go in the order of 1, 3, 7. Okay, it looks something like that. Awesome. Now, simply all I'm going to do is I'm going to take an arrow. Okay, I'm going to take an arrow and I'm going to draw each input value to their output. Okay, so when I input a 2, what is an output? A 3. So I'm just going to draw an arrow from the 2 to the 3. Next order pair, 4 to 7. So I'm going to draw an arrow from 4 to 7. Lastly, 6 to 1. Okay, good. Good. So that's representing this information as a mapping diagram. Lastly, I'm going to represent this information in a table. Okay, in a table. So as a table, this is something that you see all the time. So that's going to be my X, that's going to be my Y. All I'm going to do is list the data points as they appear. Okay, so it's going to be 2, 3, 4, 7, 6, 1. Okay, good. So I just represented all that information in 3 different ways: graph, mapping diagram, table. Now, the whole point of this question is to determine whether this information represents a function or not. Okay, so I really want to know, is this information a function? Okay, now how am I going to do that? I'm going to look at the graph. Okay, now let's just go back to the definition. So a function is a special type of relation that pairs each domain value with exactly one range value. So like I said, A4 can only output a Pepsi. So the simplest terms is you're going to look at your X values, right? You're going to look at your X values. Now, do your X values repeat? 2, 4, 6, 2, 4, 6. No, they do not. So in this case, this would be a function because none of your X values repeat. Because if your X values repeated and they had different outputs, then it would not be a function. An easy way to look at it as a graph is that if you have points that lie on top of each other, like such, say if I had 6 comma 1 and there was another value like 6 comma negative 2 here, see how they lie on top of each other? In that case, you have double X values that output different Y values, so it would not be a function. So in that case, this is not part of my data set. So then yes, this is a function. Okay, yes, this is a function. Now, let's determine that using a mapping diagram. Now, the easiest way to look at a mapping diagram and display if this is a function or not is the same. Look at your input values. Okay, are there any input values that have double arrows coming out of it? Meaning, does your x value repeat with any other output? So 2 only goes to 3, 4 only goes to 7, 6 only goes to 1. So in that case, only one arrow goes to each, and yes, that indicates it's a function. Okay, lastly, you're going to go to your table. Okay, simply look down your x column. Do you see any x values that repeat? 2, 4, 6? I do not. So then in this case, it is going to be a function, so yes. Okay. Now, next, what I would like you to do is display these ordered pairs on your graph. Okay? Then I want you to represent it as a mapping diagram. I want you to represent it as a function. Now, understanding what I just taught you with the prior example, I want you to determine whether this is a function or not. At the bottom, just write yes or no. Okay, this is not a money problem, this is just a practice problem. If you need my help, please raise your hand. Pause the video once you are finished with this example, and I will check it. You will resume the video to finish taking notes. Okay, lastly, we are going to determine whether a graph or a data set is going to be a function or not by something called the vertical line test. Now, when I talk about a vertical line test, first of all, what is a vertical line? It is a line that goes from what direction? It goes from up and down, so it looks something like that. So I have a vertical line right there. I'm going to change the color. Let's go with a red. Okay. Now, what you're going to do with this vertical line, I think this might be the easiest way to determine whether a graph represents a function or not. So you're going to take your line, and you are going to, you can do this with a ruler, you could just draw lines across your shape or figure on your graph, and you're just going to bring it from left to right across your graph. And if at any point this vertical line touches your graph more than once, then it is not a function. So in this case, where does your vertical line touch your graph? It touches it there, and it touches it there. Okay? So like I just said, if it touches more than once, okay, it is not a function. So how many does it touch? 1 and 2. So this is not a function. Okay. Good. Let's try the second example. So I'm going to take my vertical line. I'm going to go from left to right. Now, let's stop it right there. How many times does it touch? It only touches once right there. Let's move it again. Right there. It only touches once. Let's move it again. Right there. It only touches once. So in this case, I went from left to right, and it seemed that it only touched it at one point at a time. So in this case, this is a function. Okay, good. This is actually a quadratic function, which we'll be getting into sooner rather than later, but that U-shaped parabola graph is something you should be used to. Okay, so this is the end of 2.1 relations and functions. What I would like you to do now is take the information from the first two examples, and you're gonna go through the practice set. For practice 1, you're gonna illustrate this information as a graph, a mapping diagram, and a table. Then you are going to represent if this is a function or not. Okay? Good luck. Once you finish your money problem and it's checked, please go through your midpoint check problems and your practice. See you next time.